Hi there, my name is Liz Farquhar, and this is my lab mate, Tessa Davis. And we did our project on conceptualizing and quantifying the function of beaver dams and stormwater ponds on the hydrology and biogeochemistry of urban streams. And our study took place in Durham, North Carolina.
So in urban environments, the high level of impervious surfaces causes water to flow quickly across surfaces, pick up nutrients from a variety of sources, and deposit them directly into streams rather than properly infiltrate into groundwater. As a result, urban streams are characterized by wide chemical variability, and their discharge levels are highly responsive to storm events. Beaver dams reduce stream velocity, increase base flow, decrease storm flows, and enhance nutrient processing rates. Our study aims to quantify the impact of beaver dams on urban water quality by first using discrete synoptic data gained from field observations to represent the impact of beaver on carbon flux dynamics in the primary stream, and second, using local rainfall data, continuous water level observations, and discrete discharge readings to establish a base flow and compare flood attenuation potential between sites.
So the way that we did this was we implemented these little sills in the bottom left corner, and we would put them at the outlet of these different sites which connected the marsh to a primary stream. And then sometimes we would go out and we would take measurements in that primary stream of dissolved CO2 and also the carbon flux. The results from these are plotted here. Figure 3 is the water level, and the top graph here is precipitation, so you can compare the two. These feature all of our sites, including bioretention ponds, but the first two are just beaver ponds. So that's kind of what we focused on for this presentation. And then down here, figure 4 and figure 5, these are our carbon that came from the synoptic measurements. And figure 4 is the carbon flux off of the water, and figure 5 is the dissolved CO2 in the water.
So we find preliminary evidence that water flow is better attenuated in beaver marshes than in man-made stormwater ponds during both wet and dry periods, and that beaver marshes have the potential to both increase and decrease rates of CO2 release depending on hydrologic conditions such as stream discharge. Future work is needed to validate these initial findings and to explore their implications for the processing, uptake, and removal of nutrients from these environments.
And we just want to say thank you, Dr. Diego Riveros Irigui and Creedy, for all your help. And yeah, that's our presentation.